Now it's my pleasure to introduce our next speaker, David Dalrymple, known as Davidad to his fellow researchers. He's a research scientist at Protocol Labs. Davidad will lead us on an exploration of some avenues for interoperability between R&D road mapping, retrospective impact evaluation, impact certificates, project tokens, and prospective funding schemes as part of an ecosystem for provisioning public goods. Take it away, Davidad.
Thank you so much for that introduction, Carla. Okay, so sort of overview of what I'm hoping to cover here. First, I'm going to talk sort of about taxonomy of different kinds of goods, different kinds of funding transactions, because there are a lot. They have differences and things in common, and a lot of this is going to be review for those of you who have a background in this area or who have been watching this event live or chronologically, but just to make it self-contained and sort of give my own perspective on that. Then section 2 is sort of the main contribution from a novel research kind of perspective. I'm proposing a new primitive that's an interoperability layer, sort of analogous to the interoperability layers that enable transfers between different NFT platforms, or as Juan alluded to, that enable transfers of stock certificates between different brokerages and things like that. And finally, just a very brief kind of zooming through the space of different kinds of possible mechanisms and a little bit about road mapping and how that all fits in with this kind of interoperability concept. So starting with the taxonomy. So some characteristics of goods. Rival goods are goods that, if you benefit from them, detract from others' capacity to benefit. Excludable goods are things that somebody can exclude other people from benefiting from. Transferable goods are goods that somebody can give all the benefits from to someone else. Divisible goods are goods that you can feasibly and in a natural way split into smaller pieces that are still valuable. And fungible goods are goods where there's a bunch of perfect copies, perfectly interchangeable copies out there in the world. And these are all a little bit orthogonal. You can have any combination, any of the 32 combinations of these 5 properties in some certain classes of goods. So for example, fuel or oil of a particular grade have all of these properties. If you burn that fuel, no one else can burn it. If you have the fuel, you can not give it to someone else. If you have the fuel, you can give it to someone else if you so choose. You can split 1 gallon of fuel into 2 half gallons, and when it's graded as a certain quality of fuel, it's presumed that there are many interchangeable gallons of that grade of fuel. A specific iPhone mostly has these properties, but it's not divisible. You can't split 1 iPhone into 2 half iPhones that are still valuable. Ocean fisheries are an interesting example where they're non-excludable, but they're still rival. You can't stop people from fishing in the ocean, at least not without prohibitive costs. But if someone does take fish out of the ocean, that depletes the fish and detracts from others' capacity to benefit from those fish. Radio broadcasting is neither rival nor excludable, but it is transferable. You can rebroadcast to another part of the world, but you can't exclude your neighbors from hearing the broadcast that you hear, nor does your benefiting from that broadcast detract from your neighbor's ability to benefit. Cable TV, on the other hand, is excludable but not rival. Or an encrypted satellite broadcast. You can stop someone from benefiting from that by not giving them the key, but if you do give them the key, it doesn't cost anyone anything, so it's not rival. I'm mostly going to be talking about non-rival goods. I think I even put that in the title. But excludability is this orthogonal dimension. So I'm now going to zoom in on the relationship between rival and excludable goods. So the standard goods like commodities and consumer goods are both excludable and rival. Then when they're rival but not excludable, that's what economists following Elinor Ostrom call commons goods or common pool resources. When they're non-rival and non-excludable, then economists call those public goods. And that's actually most of what we're talking about here at Funding the Commons. It's actually public goods. We're talking about things that are mostly non-rival. And then this final category is toll goods, which is where it's not rival. There's no marginal cost to it, but someone has gotten control over it and put a marginal price on it, even though there's no marginal cost. So what about knowledge? I'm particularly interested in, and PL is as well, I'm particularly interested in funding knowledge. There are different aspects. Creation of knowledge is a public good. And preservation of knowledge is also kind of a public good. And it's non-rival in the sense that it didn't cost anything more for Theon of Alexandria to preserve the manuscripts of Euclid for 1 million people than it did for him to preserve it just for his daughter. So preservation of knowledge is non-rival, but public access repositories like Wikipedia, if you're a Wikimedia Foundation and you serve 500 million people a day, the marginal costs, although they're small, they add up. And it ends up being rival. So that becomes a commons in the sense that there could be a tragedy of the commons if people don't pay, if not enough people are willing to fund public access repositories for knowledge or for data. So that goes in the common goods category. Then there's also toll goods for knowledge. So patented knowledge that you need a license to use. It's non-rival and no one else is detracted from because you are benefiting from the knowledge, at least not in a direct way, but it's excludable because you need a license. Private repositories also, you need access. It doesn't detract from other people's ability to benefit, assuming the number of users is small and the marginal costs don't add up to something significant. So that's a toll good. And then the profits from toll goods, the access charges that someone is requiring you to pay, those flow to someone, and the right to obtain those profits is a private good. That's something like money or like stock equity. Control is actually a separate private good, although it's usually bundled in the contemporary intellectual property regime. Control and right to profit are bundled. And one thing which I believe strongly is that those should be a little bit less bundled. And finally, bragging rights are excludable and rival. If someone's claiming credit for having discovered mRNA vaccines or having discovered the cosmic microwave background or something, that detracts from other people's ability to brag that they discovered that same thing. And it's also something that's sort of excludable in the sense that someone can contest your claim to having the bragging rights for creating some knowledge. So each of these has some different economic characteristics, or at least a different role in the functioning of the economy. And so I'm primarily going to be talking about funding public goods, in particular creation of knowledge, but leveraging all these other types of goods to do so, particularly toll goods. But aren't toll goods bad? So this is something, I think a lot of people here probably will be familiar with this kind of ideological debate that says, if it's in no marginal cost to share knowledge or to share code, then isn't it just imperative that you allow people to benefit at no marginal cost? And then someone else says, well, if you don't reward the creators, then there's sort of this dynamic inefficiency. I'll refer to Schumpeter and say things just civilization wouldn't create knowledge, or at least not so much, were it not for toll goods being permitted by the government. And then, the counterpoint, creators love to create, they're still going to create stuff. They're not motivated by massive upside. Okay, so I'm not going to rehash that argument. I've got a new argument to contribute that's sort of just taking a completely different angle, which is making a good that's otherwise public excludable enables you to have this truthful revelation mechanism for how valuable that good is to civilization. You can assess the willingness to pay from a bunch of people by excluding people from it unless they pay a certain price. You can even improve the resolution of that mechanism by doing a VCG auction, so an incentive compatible auction for access to the toll good, and that way you can get a sort of ground truth assessment for how much utility it provided to civilization as a whole. Now, I've got a bunch of huge asterisks in here because This is assuming what's called transferable utility or quasi-linear utility or risk neutrality. All these are different words for this very common economic assumption that everyone's utility is linear in something called numeraire, which then gets instantiated as money. And that's just not true. Obviously, through experiments and also from first principles, one can argue that the value of money is probably logarithmic. So there's a bunch of huge asterisks here, but it's a very common kind of assumption, and it sort of works for the free market in other contexts. So I'm not going to dig into that too much, but just wanted to flag that as a caveat. Then the future prospects of getting this ground truth valuation of how much did you provide to society can provide incentives for prospective funders to sort of go prospecting, betting on initiatives that may produce public goods, which then get valued and receive this profit or revenue stream of tolls. That's not necessarily the only way. So the components here are basically, there's a mechanism for retrospectively quantifying value after you've resolved the uncertainty of, is this project even going to succeed? And then a mechanism that incentivizes the funders to make bets on this. And another sort of aside on the ideological thread, I think a bunch of the Stallman freedoms, the right to study the knowledge that you are using, the right to modify it for your own purposes, the right to share modifications with other people, I think a lot of that can actually be made compatible with toll goods. It's just that when you're sharing with other people, there's also obligations for them to pay tolls. And I think it's important to think carefully about that when we get to that point. Okay, so, and I want to talk about how there's a spectrum of cost in knowledge creation, from embarrassingly cheap. The Wright Flyer was invented on a less than $2,000 budget in 1903. It's about $70,000 in 2021, all the way up to discovering the Higgs boson. On the cheap end, you might just get one person who's like, yeah, an airplane would be cool. You know, I'll pay $100,000 for an airplane to get invented, and then I can have it. It'd be great. On the expensive end, you know, you're not going to get a group of people together who self-interestedly want to contribute a total of $7 to $10 billion to discover the Higgs boson. You can only do this by getting together a huge collection of people, and this is exactly the role of government, at least in a purely sort of quasi-linear economic theory. The role of government is to bundle together discovering the Higgs boson, discovering the cosmic microwave background, all of medical research, and while we're at it, education and national defense. Bundle that all together and sell it to you for a tax, and sell it to everyone all at once. So that you just rope in everyone into this giant coalition where it really is arguably worth, $7 to each of a billion people to discover the Higgs boson. And then in the middle is where it makes sense to finance things, for prospectors to kind of take bets on financing things and gather the self-interested coalition, a larger group of people who actually benefit from it later. And the toll mechanism provides a way to do that, although not necessarily the only way. And improving the market structures and the liquidity for assessing and rewarding the benefits from public goods can extend the feasible range of that sort of investment, maybe into the hundreds of millions rather than just the tens of millions. Now, there's another taxonomy I want to mention is timing. So prospective funding, of course, happens before a good is produced. There you have an actual causal impact, but you have the uncertainty of whether the team is going to succeed, the uncertainty of whether the project is even possible, how much value it will be. And there's an information asymmetry there. The team that you're funding has more information than you do. So there's a market for lemons kind of situation. On the other hand, retrospective funding, much easier to evaluate something once it exists. But on the other hand, there's no causal impact. But on the other hand, if you announce that you're going to be doing retroactive funding later, people might bet on that. Bountied funding is where you announce in a formal way that you're going to do retroactive funding for a particular thing. So that kind of helps eliminate the uncertainty on both sides. As a project that the funder is going to value something, and the funder knows that they're not going to have to pay unless and until there's a success that meets the conditions. But disadvantage is you have to think about what sorts of things you want to see happen and accurately articulate what the success conditions are and accurately assess how much you'd be willing to pay for it. You have to do that all in advance as a funder or as a funding intermediary. So it's important to have a structure to route some of the after the fact rewards back to people who funded things prospectively with the complete uncertainty. It's important to retain the option to give completely no strings attached grants. That's an important part of the funding ecosystem, especially when it comes to sort of regulated nonprofit structures who sometimes can't receive too much in return for their funding. But it's in order to extend the scope of what we can fund, we want a way for the prospective funders to obtain the rights to some of the retroactive funding. So some of the types of things that the funder might be able to get in return could be nothing, no strings attached, could be just bragging rights. And that's sort of the way that the NFTs for science movement is going, is what you're buying is a tokenized certificate that you were the one who funded this or funded a certain fraction of it, but you don't get anything more than that. You could be getting a right to retrospective rewards. And that's sort of where certificates of impact come in. You buy the certificate of impact, and then other assessors come around and say, okay, was this impact good? Okay, yes, I'm going to pay rewards. And who am I going to pay them to? All the people who are holding the certificates for that impact. And in the transferable case, we can also separate these sort of altruistic retrospective rewards where assessors come around and pay in exchange for nothing, just saying like, all right, good work. Here's your retrospective funding to pay back your financing costs. Reputational rewards where someone else wants to buy the bragging rights from you. For example, in that kind of ratchet auction situation that the last speaker mentioned, or toll-driven retrospective rewards. And this is often the case with VC funding where you're actually saying, okay, I want a share of your profit stream if you're going to then create a public good that you assess a toll for. So this generates this sort of 3x4 matrix when we combine the timing with the what does the funder get in return. So there's results oracles, there's bounties, there's impact grants, impact investments, project tokens, VC funding, startup acquisitions, retro PGF. All of these kind of fit somewhere. They have a niche to fill, and I want all of these to work. Want to enable all of these to happen, especially at an experimental stage, and I want them to work together wherever possible, so that we don't have there's one platform where someone's doing prospective funding, and there's some other platform where people are doing retroactive funding, and then they don't talk to each other, and so the people who did the prospective funding miss out on getting the retroactive funding. Would be unfortunate. So then I want to talk about interoperability. So this is sort of the mathematical thrust of the talk. So there's a lot of math in here, but it's also conceptually, I think, pretty straightforward. So I hope to convey that as intuitively as I can. So what I'm proposing here is a new kind of ledger, or maybe a new ERC standard, not necessarily a new blockchain or anything, but a new kind of token-ish asset. It's sort of NFT-like. But fungible in one dimension, sort of like stock certificates. As Juan mentioned, having that fungibility makes a lot of bargaining things a heck of a lot easier, but then it's non-fungible in other ways. We want to facilitate allocating retrospective rewards to prospective rewards and support these hierarchies of credit assignment, but without imposing a mechanism that everyone has to use. So that saying you kind of bring your own mechanism, bring your own bargains, but now you can have all of those mechanisms and bargains compete and collaborate and nest in each other in one interoperable platform. Okay, so the idea is, I'm calling it a hypercertificate. A given hypercertificate specifies some set valued parameters. First of all, the set of included rights. Bragging rights are included by default. I think you're always going to have bragging rights if you own a tokenized certificate of some kind, but it's what other rights do you have? The rights to what other kinds of rewards. There's a certain set of contributor identities. So one of the fundamental conceptual ideas here is that we're not tokenizing impact exactly. We're tokenizing the contributions of certain people who all must have agreed to sort of participate in the scheme. So who are the contributors that are included? What's the scope of work that's included? That's an obvious one. In some cases, you might, if you're funding people, not projects, you might say, I'm going to cover all the scope of work becomes degenerate in that case. You're funding a person, all of their contributions, but within some particular time intervals. That's another dimension. During what time interval are the contributions included? And then a final dimension is during what time interval are the public goods consumption included? The degenerate case for that is any time from now until forever, I want to include in this certificate the impact that occurs no matter when in the future it occurs. But in some cases, you might want to only bet on certain time intervals of success. So the notation here, I'm using H subscript X of a set, which is a product of these 5 sets. And HX of that set is going to be a number between 0 and 1, which is how much of that set does identity X own. And the invariant here is that for any point in the overall product space, the total amount of hypercertificates that exist and cover that point is either 0, it's an unclaimed territory, or it's 1. There's 100% that is accounted for. So no double spending and that kind of thing. The intuition here is that these are territorial claims on regions of public good space where there's a bunch of dimensions, five dimensions, and then an extra one for fungibility. So there's a 6-dimensional space, and a hypercertificate represents a claim on a hypercubic region of that space, thus the name hypercertificates. So minting, the presumption is that everyone owns all the rights to their own contributions. There's no other checks that are necessary for minting. So if you're an individual and if you've got a proposed region of space, region of public good space that's in your slice of it, your slice C of the contributor dimension, and it's never been minted before, then you can sign a transaction and you can mint it and you can assign 100% of it to yourself. That's how minting works. You might or might not have actually done anything in the scope of work that you've claimed during the time interval that you claimed, et cetera. But whatever you have done, you own, and you can track that on the ledger. So that's minting. Then merging and splitting is really the core of this. And the reason for that is that liquidity is a lot better when you can pool, when you can bundle the contributions of a bunch of people to a particular project, effort, company, or whatever, up to a level of abstraction where a bunch of people can, where it's worth it to sort of analyze at that level of abstraction, where and where there's enough demand for buying and selling that you can get a price. So you want to add up contributions, want to bundle across people, across time, across projects, but only just as much as you need to get the liquidity that you want. So the flexibility here is key. But we want to build into the ledger the bookkeeping for merging and splitting, but without imposing a particular fairness norms a priori about how the resulting bundles should be allocated between participants. So the merging conditions is, if you want to merge some things together, you have to own, one person has to own all those things, and they have to union up to a set which is also a Cartesian product, so that the representation of that set on the ledger doesn't become combinatorially expensive. If that's the case, then one signed transaction can deduct a quantity Q of all of the individual pieces from your balance, and then add a quantity Q of a hypercertificate for the entire union. Splitting is the same thing, but in reverse. If you have a certificate and there's a bunch of valid specs that union up to it, and you want to split into you want to split your ownership into those, then you can do that as well. And then this is really the technical centerpiece of the whole talk. And if you tuned out from the math, this is the last slide for math, more or less. So if you've got a bunch of certificates SI, and you have a proposed division of certificates TJ, which union to the same total region of public good space. Okay, and if you are a coalition of K cryptographic identities who collectively own at least Q of every SI, and your TJ, and you have a Q sub JK, you have a proposed reallocation of that Q back to each of the K parties, and with each of the J different splittings that you want. In many cases, the output of this will just be one. There will be a T sub 0, which is like the overall thing, will be equal to X. But in general, you can merge and split. So you do a one multi-sig transaction that everyone signs. You can bundle arbitrary side payments with that if you wish. Then that one transaction can merge all of these individual certificates, say, okay, I'm going to union the contributor sets, union the time intervals, union the scopes of work, and then split back atomically so that everyone has a certain share, which they've all agreed to in the multi-sig, of the overall impact, or potentially splitting it along different axes. And so what this does, what all of these conditions ensure, is the invariant is the same. There's no double spending. Everyone who's involved has agreed to this way of allocating things, but there's no constraints on the way that you allocate things. They just all have to add up. It's just balancing the books. So you bring your own bargain, do your own bargaining mechanism, define your own side payments. This is a platform that should be able to support experimentation with a bunch of different mechanisms for deciding what the splits should be when you do these transactions. Okay, and then there's this concept of burning, which I'm just gonna zoom through. So bragging rights arguably should be permanent. There's a sort of double spend of bragging rights that happens if I do a brag, hey, I own this thing, and then I sell it to someone else, because people will still remember me as having been the person who owned that thing. So there's this concept of saying, okay, look, if I own the time of fruition from now to infinity, then I should be able to just burn that and have that belong to me forever. And then my bragging right is sort of more justified. I get a ultra bragging right. And also, if you ever burn 100% of all of the rights to toll income, that means that somebody has basically footed the bill for that public good. That no longer do you have a justification for excluding people if they don't pay the toll. So that's sort of an exit off-ramp from any kind of licensing regime that gets applied to these things. Now, assessing, this is important. You're never going to completely comprehensively cover all of the contributors that contributed to a certain outcome in the world. You're always going to be looking at a collection of people that is finite, and assessing their impact counterfactually on a particular thing having happened versus some kind of default. And that's always going to be subjective, I think, because it involves counterfactuals. There's no way that you can go out and measure what would have happened if these contributors hadn't been there. So there's this role for independent auditors and assessors. And again, I'm not proposing a solution. I like a lot of the ideas from the previous talk about assessment. And in particular, I think it's important that assessors should have one utility function that they apply universally. They say, like, look, how much improved utility for the world did these contributors work in this area during this time produce counterfactually, or in Shapley value, or what have you. But these are third-party rating agencies, basically, and the model for that is things like Moody or Standard & Poor's in bond markets, and it's not the most incentive compatible, but I think that's probably good enough to start with. So this system is permissionless but not trustless. These assessors are trusted third parties who sort of give a stamp of approval to your bragging right and say, yeah, this really did cover sort of 98% of the impact that it claims to, or something. It meets a certain standard. And for toll income, there's sort of existing institutions and norms for who counts as an inventor. And Shapley value, I'm running low on time, so I'm just going to say Shapley value is a great concept, but it still has these free parameters in terms of what's the utility function and what's the universe of contributors that you're considering. But I do think trying to approximate Shapley value is a great route in the mechanism space. And then there's this whole bunch of collective choice mechanisms, which I knew I wouldn't have time to talk about, so I've just listed them. And I want to be able to apply any of these, and to basically any prospective funding, retrospective funding, bountied. All of these are just ways of making collective decisions. Some of them are more suited than others to coalition forming or balancing a budget. And sort of what's the perfect way, or what are the pragmatically most effective ways of doing different kinds of funding rounds. That's sort of open for both theoretical and empirical investigation. And all of this can be sort of implemented as smart contracts on a platform where the output is a bargain that allocates hypercertificates. And then finally, I want to talk a little bit about road mapping, just to give a picture. This is an example of a sketch of a roadmap for at a very high level for AIX risk. A formal roadmap would also specify probability distributions for each milestone, conditional on their inputs. And so what is R&D road mapping for? It's for helping funders and contributors and hypercertificate assessors and auditors and their delegates, all of these kind of participants, to define their consistent utility function. That's what road mapping is for. It's saying, look, I've got some terminal goals that I've attached utility functions to, and then I want to back propagate how much should I be willing to pay for partial success on intermediate milestones and various combinations based on a stochastic causal model. And doing this properly would be, I think, a strict improvement over not to diss it, but the important tractable neglected kinds of heuristics for what's worth funding. All of that would be folded into what's the improvement in utility when I apply the roadmap to the potential intervention. Okay, so in conclusion, there's a huge landscape to explore with different combinations of what sorts of toll goods or private goods we can carve out and price that are associated with certain public goods, different kinds of transaction structures with different timings and covered time intervals, different kinds of bargaining and collective choice schemes and model making tools. And ledger technology can help automate the bookkeeping down to a finer scale of granularity than would previously have been possible. And I think a hypercertificate concept can support all of this coexisting without sort of having to bet on a certain platform or a certain way of approaching prospective versus retrospective. All of this can happen on a single platform where you can know that a certificate on that platform is going to be around no matter which funding mechanisms are going to be in use next year on top of it. Just like with NFTs and NFT platforms, the NFT standard ensures that. And then finally, yeah, if you're interested in working on building, I haven't thought about any of the implementation details of this, but I do think this should be built, and I can probably get you funding to do so. And this is a very exciting moment because the reason I can confidently say that is because of the work that's been done by previous speakers to actually implement mechanisms from previous iterations of funding the commons. So we can now bootstrap the next generation. We've reached criticality on funding public goods mechanisms. And with that, thank you very much. And thank you to my collaborators and conversation partners.